Hi, hello friends. Welcome to today's session. Welcome to Unacademy and welcome to Srinivasarao classes. In this session, we are going to learn about the delays in network or network performance parameters. So, before discussing about network performance parameters or delays in the network, we will say our anthem crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's topmost educators. So, dear friends, we all know that Unacademy has created wonderful environment to get the online content from top quality educators to clear all your dreams. Your dream is our dream, and our dream is Unacademy. So, Unacademy is working hard to fulfill all your dreams. So, student satisfaction is Unacademy's motto. So all you need to do is take admission from Unacademy and get the unlimited live classes and live quizzes, mock sessions, whatnot, everything whichever is available in Unacademy's portal. And myself is Srinivasarao IS, having more than 15 years of experience in the GATE with the various subjects. I also had industry experience with a good number of certifications in database side, networking side, and operating system side. So, my dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate, and many of my students got completed their post graduation from IITs and IITs and central universities. So you also can achieve such kind of success as they are already settled in topmost companies either in PSUs or campus placements. So all you need to do is just to clear a prestigious competitive examination called a GATE. So once you clear the GATE examination, then you're going to settle in your life. So there are two kinds of subscriptions which are providing by an academy. One is for 12-month subscription. The current fourth year students can opt for this. The other one is a 24-month subscription that can be opted by first and second and third and fourth year students. So my dear friends, I use my referral code to get the maximized discount. And apart from the top quality content which are providing by top quality educators. So first year students also can start their GATE training program because as they are going to study C and data structure subject, this is one of the important subjects in your engineering curriculum. So Unacademy is also going to provide a 1:1 guidance program which including of your plus courses known as Iconic Batch. You can also join into Iconic Batch. Therefore, you're going to get all kinds of clearance from your doubts. So if you would like to interact with any faculty member, please fill this form and Unacademy is going to direct a faculty member so that you can able to clear all your doubts. So let's crack GATE CSC is our YouTube channel. Subscribe our YouTube channel. Hit the bell icon for latest notifications and updates. I use my referral code Sankara to get the admission into Unacademy. My dear friends, let us start our agenda, that is delays in data transmission. So why the delays are going to be shown some impact on your network. So this is a very important term. So you all know that a concept called a bandwidth. A bandwidth is nothing but actual. So actual transmission is called as a throughput and in principle transmission is called your bandwidth. Therefore, there is a lot of difference between your bandwidth and your throughput. When I am saying that a bandwidth, this is in principle without any delays. And when I am saying that there is a throughput, this is called which consists of delays. So my dear friends, this is how and why we are referring and learning the importance of delays whenever you are transmitting your data via network. That means due to congestion, your bandwidth you may not get 100%, or due to collisions, your bandwidth may not able to get 100%, or due to longer distances, you are unable to get your bandwidth 100%. So there are many factors which involve why we are unable to get 100% of efficiency, why we are unable to get 100% of efficiency, therefore why we are unable to get 100% of throughput. So if you get 100% efficiency, your bandwidth is exactly is equal to your throughput only. My dear friends, you observe carefully what I said. The important point is that when I am saying if your link efficiency is 100%, then I can able to say that my throughput is equal to, throughput is nothing but actual transmission is exactly is a given bandwidth. That's why in real-time data transmission, your throughput is always lesser than to your bandwidth because there are many parameters are involved while transmission of your data. For example, you want to know that how much bandwidth your internet as your internet service are providing to you. So just you go to your Google and type a site called speedtest.net. So naturally we used to do in the industry, whenever you say that speedtest.net, then it is going to give you a site where you can able to see that what is your upload speed and what is your download speed and what is your pinging response time. So that means if your distance is far away, then you're seeing that you're going to get a ping response time is a little bit bigger than your local area network. So based on your ping response time only, I can able to say in general that there are different varieties of networks like LAN, MAN and WAN. When you talk about the WAN, the distance is so far, therefore ping response time is also going to be far. When I am saying that LAN, you can able to see that the ping response time is going to be very less. That's what you want to know, what is the actual throughput you are getting or in actual bandwidth you are getting and how much is the upload capacity and how much is the download capacity. They all depends upon your distance and other particular parameters also. So this is a mandatory requirement. What is that? If I say that your link efficiency is 100%, then I can understand that 100% your throughput is equal to bandwidth without any doubt. Therefore, my dear friends, when I say that bandwidth, which is nothing but in principle capacity, in principle transmission speed, and when I say throughput, this is actual transmission capacity. So actual is nothing but actual bandwidth is nothing but throughput. In principle capacity is nothing but your bandwidth of the channel. So now the delays are going to differentiate bandwidth and throughput so that you will well understand why the throughput is always lesser than is equal to your bandwidth. So likewise, if you understand. So the first, these are being divided into different varieties. One is at sender side, one is at receiver side, one is at message side. Receiver side is nothing but receiver side node. It may be a direct receiver or it may be any intermediate router. And the sender is nothing but which may be a sending side. It may be a direct sender or which may be an intermediate router. And the other one message side. So message is having a queuing delay and a data propagation delay and acknowledgement propagation delay. So my dear friends, according to that, let us see what is the data transmission delay and what are other particular delays which are mainly used in data transmission. So simple example before discussing about these delays, I want to give a simple example here. When I am saying that there is a sender side and there is a receiver side, I say that I am limiting to a shorter distance. Whenever you say that shorter distance, then as I said that my ping response time is going to be very less. You may be asked a question that what is the meaning of ping response time? Ping response time is nothing but I have sent you a request then I'm going to expect a reply from you. This is your ping response time. Or data transmission and acknowledgement arrival time. You can also call like that. That is the meaning of pinging. Now, if I'm saying that this is taking a somewhat going and coming back, it is taking a 5 ms time if I'm saying. So this may be vary in metropolitan area network, because in metropolitan area network your distance is a longer than your LAN. So I can say here that your distance is a somewhat longer. Therefore, what is going to happen? Here is the sender and here is the receiver. And this time I am expecting a ping response time. So going there and coming back, we assume that as your distance is increased, then your data transmission time on the media is also going to be increased. I'm saying that one side it is taking a 20 ms and the other side it is taking a 20 ms. So now I'm going to compare with your wide area network. You know, wide area network means a vast distance. That means a huge distance. This is a long distance. So you want to sense the data. That means what? You want to see the data is pushed to other side, and I'm expecting acknowledgement from other side. So acknowledgement will give you a lot of confidence that your data has been arrived to some other in a secure form and in a safe form. Now, as I increase the distance, then your WAN distance is a much bigger than and longer than your MAN. Therefore, I am expecting like 100 ms. So please observe carefully here. So if it is a shorter distance, then efficiency is going to be better. If you are using a longer distance like a MAN, it is a, what I mean to say, a nominal. And if you are saying that a longer distance is a very poor, that's why according to this comparison you say in LAN you are having a good, and in MAN your efficiency is going to be lesser than LAN, and in a WAN your efficiency is lesser than MAN. This is the association. And if I am using internet, then internet efficiency is a far. We see that as its distance is a very huge than your wide area networks, and your ping response time is also going to be very less. Sometimes there may be a chance of leakages of data. That means the packets are going to be dropped. So now according to these parameters, I want to discuss these delays. One is at sender side. So what is the first sender side? It is a transmission delay. These are very important questions, my dear friends. Directly they may ask you a question. So what is a transmission delay? Also called as transmission time. So what is the meaning of transmission time? The meaning of transmission time is nothing but time takes by a sender to place the data onto media or a link. Again, I am telling you, time takes by a sender to place the data onto media or to link. It may be sender in the sense it may be original sender, it may be any intermediate router which is trying to push the data to other links. If I am saying that I am direct sender, so sender is transmitting the data to your media. Now I am taking a channel between them. This is the channel. Now sender first of all has to place the data onto media. So how much time the sender is taking to push your data units on the media, that is the meaning of a transmission time. So whenever you push your data onto the media and the sender is relaxed now because he already pushed the data, now it is the time by your medium to place your data from one particular node to other particular node. So here what is going to happen? This transmission time, whatever we are discussing, time takes by a sender to push your data onto the media or to outgoing line is a concept of TT, which is mainly depends upon your bandwidth. So TT depends on bandwidth. If you are having a huge bandwidth, then your transmission time is a very less. If your bandwidth is very low, then your time transmission time is going to be very high. That's why you see real-time example is a bandwidth. I'm uploading something. If your bandwidth is what I mean to say lower bandwidth, then it takes a lot of time to upload it. Like in WhatsApp also, you want to send something, it takes something. It takes some time, wheel is rotating. That means what you are unable to have to transmit it because your bandwidth is not supporting to you. That's why it all depends on your bandwidth. If I take a very vast bandwidth, then it takes a very minute amount of time just to push your data onto the medium. That means whenever you send, immediately it will not go. First of all, it is trying to place your data onto your medium only. Therefore, it depends upon your bandwidth. What I said, if bandwidth is increased, then I said that your transmission time is going to be decreased. Proportionately, if I am saying that your bandwidth is decreased, then it takes much time to attach your document, or it takes much time to put your document in the WhatsApp also or in the mail. That's what. So if bandwidth is very less, then the time transmit to your place your data onto the media is also going to be very high. So that's why it's completely depends upon your bandwidth. And one more parameter is also there for your transmission time, that is your message size. Observe carefully. So it also depends on your message size only. If my message is for example 100 MB, 100 MB I want to attach, it's very difficult in a normal general bandwidth. That's why you cannot send directly using a Gmail. Your Gmail maximum capacity of your attachment is 20 MB only. So you want to send more than that, then there is a requirement of what Google Drive, and you are trying to give this permission, Google Drive permission to others. So it takes some time to able to push your data onto the medium because my message size is a very vast. That's why what I am saying that if message size is increased, then automatically your transmission time is also going to be increased. Then if I am saying that reverse, if a message size is decreased in a given bandwidth I am talking, then automatically then your transmission time is also going to be decreased. So these are the two important parameters which are associated with your transmission time. So transmission time completely at the sender side, that he has to place the data onto the media. How much time it takes is the concept of transmission time. Transmission time to place your data onto the media, it depends upon your message size and it depends upon your bandwidth. This is the concept how you can able to push your data onto the media. It takes some time. That time is nothing but transmission time only. Now let us say an example like this. If my bandwidth is equal to 1 bit per second, so what is the meaning of that? Every second I am going to transmit 1 bit. For every 1 second I am capable to push one bit to your medium. So this is one example. If I am increasing, for example, I say if my message size, observe carefully, if message size is also 1 bit, observe carefully, if message size is also 1 bit, so how much transmission time? How much is the transmission time? I can say that just I am taking a 1s to push 1 bit onto your medium. So therefore you will to transmit every 1 second I am able to transmit 1 bit onto your medium. So if I am saying another example here that my bandwidth is like that only I am keeping. So my bandwidth is equal to fixed 1 bits per second only. Now I want to send a big message, not 1 bit. So what I am going to say, message size is going to be something like 100 bits I want to transmit. So what will happen? Your TT is going to be increased. That's what the rule I have written. Whenever message size is increased, automatically TT is going to be increased. What is your TT here? 1 second, 1 bit. So I want to transmit 100 bits. So how much time it is going to take? So this I can able to get using a concept of what? Your message size divided by your bandwidth. Message size is nothing but length of the message, which is denoted as a L. and the bandwidth is nothing but B. So I can write like this: length of the message divided by bandwidth is your transmission time to push your data onto media. It is L by B, which is nothing but 100 bits divided by the same bandwidth, that is 1 bit per second. So it is taking almost all 100 seconds, my dear friend. So what I said, if your message size is decreased, then TT is also going to be decreased. If your message size is increased, then TT is going to be proportionately increased. Let us see one more example. I am saying, for example, my bandwidth is equal to, this time I have taken a good bandwidth. So I am taking something like 100 bits per second I have taken bandwidth. And now I make it a constant, our message size. Our message size is same, 100 bits only. Because in the earlier example, I understand that I got 100 seconds of time. It's imaginable. Now you see, if I want to reduce your transmission time, in the sense what I am doing, I am not increasing or decreasing. Here I am not going to decrease your message size. Just I took a much bandwidth. Therefore, what is happening? Your transmission time to place your data onto the media is nothing but a length of data divided by bandwidth. So length of data is nothing but fixed, as I told you in the previous example, by your bandwidth is 100 bits per second. So here this and this is a cancel, and this and this is a cancel. Therefore, it is a what? The 1 second. So I give you two important points. You increase the bandwidth to reduce the transmission time, or decrease your message size to decrease your transmission time. That's it, my dear friends. That is the first parameter. What is the first parameter? Transmission time. Time to push your data onto the media is nothing but transmission time, which depends upon two important parameters. One is on bandwidth, the other one is on message size. Now let us see second one, that is acknowledgement processing delay. So what is acknowledgement processing delay? Let us see. So sender and receiver, they are using a same channel to transmit and receive the data. This is assumption, by default assumption this is. We assume that sender and receivers are connected to same channel only. Now sender plays the data onto the media using a transmission time for your data. And now this data has to make a physical journey from one end of the medium to other end of the medium. Therefore, this bits whatever you placed onto your medium, they are making a physical journey from one end of the media to other end of the medium. That means how much time it takes to propagate over the medium, or how much time takes all the bits which are there on your particular medium as to make a physical journey from one end of the medium to other end of the medium. So that is what is the meaning of propagation time. Propagation time of your data. So how much time a message takes to make a physical journey from one end of the media to other end of the medium. Anyhow, we will learn this after some time. So data is propagated which reached to a receiver. What receiver is going to do? After receiving the data, he is giving you acknowledgement. So what is this acknowledgement? Just he plays the acknowledgement. So for placing the acknowledgement, he is also going to take some time. It is nothing but acknowledgement transmission time, which depends upon your acknowledgement size divided by receiver's bandwidth. Observe carefully. Just it has the control information without any data. That is the meaning of acknowledgement. A frame consists of only control info without having any kind of data is nothing but acknowledgement. And it is also going to take at the receiver side some time to place your acknowledgement packet or a frame onto the medium. That's the meaning of transmission time for acknowledgement. Now this acknowledgement also has to do propagation from receiver to the sending medium. So therefore, how much time you have taken to push your data onto the medium, that means how much time it takes to make a physical journey from one end of the medium to other end of the medium. Same time the acknowledgement packet also is going to take. That is a propagation time for your acknowledgement. When this acknowledgement comes to the sender and the sender takes that, whether it is a positive, whether it is a negative acknowledgement, will take some minute amount of time. And that minute amount of time is called as what? Acknowledgement processing delay. So that time is called as what? Acknowledgement processing delay. So we will see that do we receive from correct party or not this acknowledgement, and we will also see that whether it is a positive acknowledgement or negative acknowledgement. Acknowledgement processing time. That is the meaning of acknowledgement processing time. These two are being done at sender side only. One is transmission time to push your data onto the medium, and the second one acknowledgement processing time. Let us see. So acknowledgement processing delay. Amount of time taken by your receiving router to process the acknowledgement packet. Now let us see the two other delays which are happening at the receiver side. One is data processing delay. Please observe, receiver sends acknowledgement to the sender. So sender sees that acknowledgement processing delay. But here receiver receives the data. He will open up the data and see that the data bits are corrupted or not. Then only the data frame will be handed over to your upper layer. That's nothing but internet layer. So it takes some time to process your data. So that's what amount of time taken by a receiving router to process the data packet. So who is the sender, who is the destination, and what is the packet format you are sending, all the information are there in that. So that is the meaning of data processing delay. And the next one is that acknowledgement transmission time. As I already told you, receiver places the acknowledgement onto the medium, which takes some time. That's called acknowledgement transmission time. So time takes by a sender, that means other party, time takes by a other party to push the data bits, to push the acknowledgement bits onto media. It depends on your acknowledgement size and a receiver's bandwidth So we can able to write like this, that is nothing but acknowledgement size divided by a receiver's bandwidth. The point. For data processing delay, there is no kind of any equation. It's some fixed amount which may be vary time to time. So the other one is message side, nothing but queuing delay and propagation delay. So I will give you a diagram so that all these delays will be included. Please give me some time. What is a queuing delay? So whenever you transmit your data, immediately it will not be placed to the receiver. First of all, they are being placed in the buffer. As and when the receiver node is available, they will be forwarded. That's the meaning of store and forward switching concept. Immediately they will not be delivered. Sometime router may be busy or sometime receiver node may be busy. That's why we will not send to the receiver, router or receiving node. So it takes some time. The message takes some time to be in the queue before processing your data. So that time is called as what? Queuing delay. So first of all, your data will be placed into your buffer. From buffer, your data will be pushed to your original party. So it takes some time. That time is called as what? Queuing delay. So what is a queuing delay? The time needed for each intermediate node or end device to hold the message before it can be processed. Otherwise, how much time a message takes to be held in the queue before it is arrival to a router or before it is arrival to the receiver for further processing of your data. So it may be vary based on time to time, and it also depends upon your buffer capacity. Why I'm telling you this? As we are using a concept of store and forward switching, immediately data will not be pushed to the other party. First of all, it will be stored, then it is forwarded to other party. And the next one is data propagation delay. So time takes by a bit or a signal to make a physical journey from one end of the medium to other end of the medium. That is a data propagation delay. So data propagation delay depends upon your distance and velocity of your channel. That's why in LAN, your propagation time is going to be bit lesser. If you are talking a metropolitan area network, your propagation time will be bit higher, and wide area network, your propagation time will be very higher because it depends on a distance only. And when you are talking that internet, then your propagation time is too high. When you are talking that satellite, then you are going to see the double. You are going to see the double of your time to make a physical journey from one particular point to other particular point. That's why, my dear friends, data propagation delay mainly depends upon how much distance you are traversing using your speed or velocity of your medium. The other one is acknowledgement propagation delay. So, however, your data bit or a signal is propagating from one end of the medium to other end of the medium, acknowledgement bits also must come from other end of the medium to this end of the medium. Time takes by acknowledgement bits or a signal to make a physical journey from other end to this end is the concept of acknowledgement propagation delay. So I gave you total altogether they are being segregated into three varieties, three groups. One is sender side, the other one is the receiving side, the other one is message size. Okay friends, message size is nothing but queuing delay, how much time the message takes to be in the queue before it is arrival to the router for further processing of your data. And data propagation delay, the time it takes by a bit or acknowledgement to bit to make a physical journey from one end of the medium to other end of the medium. This is for data and this is for acknowledgement. Both are for TP only. This is called propagation time both. This is called your queuing delay. And receiver side, data processing delay and acknowledgement transmission time takes by receiver to push your acknowledgement bits onto the medium. So sender side two varieties, data pushing and acknowledgement processing. So now let us mix all these parameters into a single example. Let us start sample example here. So there is a sender and here is the receiver, and both are using common channel. That means single channel they are using for transmission of your data, and they are directly connected each other. And the first parameter is observe carefully. Sender has to place the data onto the medium, which is nothing but TT for data. First, let me speak few parameters. Then, whenever this data placed onto your medium, that means what? Your message takes some time to make a physical journey from one end of the medium to other end of the medium. So the last bit in your message has to be reached to other side. So now I'm talking that this is a medium. So this kind of a delay is a propagation time. Propagation time for your data, TP for data, which mainly depends on how much distance you are carry and what kind of a medium you are using. Naturally, your speed depends upon the nature of the cable you are using. If I am using a copper, if I am using a coaxial, if I am using a twisted pair, if I am using all these three, all these three is going to take 2 into 10 power 8 meters per second. This is the speed of those three varieties of mediums. And if I use the advanced one, that is the optical fiber channel, your data transmission is in the form of light. So as a light is 3 into 10 power 8 meters per second, but you cannot consume 100% of your 3 into 10 power 8, which may be a 70% or 80%, but 100% we will not use of your light transmission. So according to the speed and according to your distance, the TP is going to be calculated. That's why TP depends upon your distance and the type of medium you are using, so that I can decide what is the TP. Anyhow, the data has come to the receiver. What the receiver is going to do? So this is the first delay I spoke. This is the second delay I have discussed. And the third one, the data received by the receiver. And after receiving by the receiver, what the receiver is going to do? It takes that particular packet or a frame he takes. Receiver takes that packet or a message. Then what he is going to do? He will start processing. What is processing? Processing of message or processing of your data. Whether your data is arrived correctly or not, whether it consists of any errors or not, it takes some time. So that's some time. That means what? Before you are giving acknowledgement to other party, I am taking some time. That is called as what? Data processing delay at the receiver side. Data processing delay at the receiver side. If I am not the direct receiver, I need to process the data. Who is the other particular party I need to push? Then I will push it. So that time is called as what? Processing of your data. Data processing delay. This is the third parameter. And the fourth parameter, you assume that all bits are correct or entire message is correctly arrived. Then what receiver is going to do? He will give you a acknowledgement. That means he just push the acknowledgement to other end of the medium. So this is the fourth one. What is the fourth one? Transmission time for acknowledgement. Please understand, transmission time of data depends on your data divided by sender's bandwidth. And here you observe, transmission time of acknowledgement is nothing but your acknowledgement size divided by the other party bandwidth. That is nothing but receiver bandwidth only. This is the fourth one. And the fifth one, whenever you place, the receiver place the acknowledgement here, whenever receiver place acknowledgement, he took some time, that is called transmission time for acknowledgement. This acknowledgement also make a physical journey from other end to our end. So this is a TP for data other direction. This is a TP for acknowledgement receiver to the sender. This is your fifth delay. First delay is a transmission time of data. Second delay, propagation time of your signal or a bit. Third one is data processing delay at the receiver side. Fourth one, transmission time of your acknowledgement. Fifth one, propagation time of your acknowledgement. That means time takes by acknowledgement bits or a signal to make a physical journey from other end of the medium to this end of the medium. Fine. So sender receives the acknowledgement. Sender received acknowledgement and he will start process. Whether it is a positive acknowledgement or a negative acknowledgement, whether it is a piggybacking acknowledgement, or whether what is the next frame I supposed to send, this are all information is available in that. So after sender received the acknowledgement, he start process it. So that's what the meaning of what? Acknowledgement processing time. Acknowledgement processing time. This is your sixth delay. Observe friends. So almost all six delays I discussed. So receiver side, packet processing delay. Sender side, acknowledgement processing delay. Now two other delays are there. They are queuing delay and processing delay. So queuing delay and processing delay. So processing delay we already discussed. Now we are going to see what is that? Queuing delay. What is the queuing delay? I already told you. before arrival of the router, as I am using a store and forward switching, and you are having some buffers before you push your data to other party, how much time the message takes to be in the buffer, that time is called as a what? Queuing. When you are going to do queuing, if at all the other party is busy, then we will see that our data packets are going to be in the queue for some time. That time is called as what? Queuing delay. Therefore, my dear friends, let me give final diagram. What is the total time? What is the total time to send successfully data from sender to the receiver? What is the total time takes for successful transmission of data? For successful transmission of data. So let us include all delays. Let us include all delays. The first one is you recollect in the order only you recollect. One is a what? Transmission time of your data. Second one is propagation time of your data. Third one is once the data is propagated, it is going to be held in the buffer. So queuing delay plus once the data received by the receiver is going to process it. Data processing, I can write that T process, data processing. Then once the data is processed, the receiver will construct acknowledgement, DT for acknowledgement. So once acknowledgement has been posted at the receiver side medium, that acknowledgement also has to do physical journey. So TP for acknowledgement, propagation time of your acknowledgement plus once the acknowledgement has come to the other party, then sender has to process that acknowledgement. What is that? T process of your acknowledgement. The T process is a what? Data. That's it, my dear friends. These are all the delays are included. So what is your total time? Your total time is equal to this much whenever I consider delays. Generally, if you look at carefully, routers are not a slower devices. Routers are very faster devices. Switches are very faster devices, which does not need any kind of a queuing delay, which does not need any kind of processing delay. Therefore, I can nullify. So I can say that this is a negligible, and I can say that this is a negligible. And one more is also negligible. What is that? Transmission time of your acknowledgement is also negligible because I am not sending data, just I am sending a control info without data, which does not take much time to construct your acknowledgement. Therefore, receiver side transmission, acknowledgement transmission time is also negligible. And the sender, he need not worry, see that how much time it is going to take. That means what? To process your acknowledgement packet is also going to be nullified. Finally, what do we understand? If you see that some of the delays are negligible, which are secondary, these are primary. This is the primary delay, this is the primary delay, this is the primary delay, and remaining are secondary delays only. Unless and until examiner asks, we will consider, otherwise we are not consider as they are secondary delays only. So once you eliminate those delays, your total time is going to be what, my dear friends? TT for your data mandatory. Sender has to place the data and the data has to propagate onto the medium. So TP for data and receiver side acknowledgement also has to do some propagation. So TP for acknowledgement. This is a mandatory. So whenever you make negligible those secondary delays, the real-time total transmission is this is only 95% cases we will negligible your secondary delays. We consider only these three important primary delays. This is the primary delay. Unless sender places the data onto media, nothing is propagated onto the medium. And unless the data is propagated onto the media, the data will not goes to the receiver. Therefore, it is also primary. Unless you send the positive acknowledgement or negative acknowledgement, sender cannot able to know that whether the data is success or not. That's why we will consider this is our important equation as your total time. Well, my dear friends, now after discussion those delays, we understand that the total time is classified into one is considering all the delays, the other one considering only primary delays. So what is the primary delay diagram? Let me write. So sender and receiver both are connected to the medium. And first of all, sender has to place the data onto the media. So using TT for data. And this data has to go to the other party using your medium help, which is nothing but TP for your data. And the receiver is going to send back an acknowledgement. So that time is nothing but TP for acknowledgement. Remaining we don't use. This and this is completely depends on distance by speed. And this is completely depends upon your message size, length of the message divided by your sender bandwidth. So 99.99% you will be asked a question on these three primary delays only. Remaining delays are secondary. If at all he asks, just you consider them. Otherwise, you can calculate your answer is like this one. Well, my dear friends, so we have discussed almost all delays. So some other parameters also we need to discuss. What are that? Round trip time. So round trip time is nothing but minimum time it takes to get the acknowledgement. That is the meaning of minimum time or round trip time, which may be maximum time also. That maximum time is called as a what? Timeout time. Observe, my dear friends. Minimum time is nothing but time takes to get the acknowledgement. Maximum time is nothing but what? Timeout period, which is a double of your round trip time. So maximum time of acknowledgement is nothing but double of your round trip time, and your round trip time is nothing but what? Make a physical journey from one end of the medium to other end of the medium. Therefore, so normally we consider round trip time is nothing but sending the data and receiving acknowledgement from other side. And still you are not getting acknowledgement. I waited for a minimum time and I waited for a maximum time. So still there is no response from others. Then simply what I am going to do? Leave your connection. The leave your connection is nothing but double of your timeout only. So see the relationship between those three. So RTT is nothing but one side propagation delay and other side propagation delay. Especially WAN RTT, this is wide area network RTT. So LAN RTT is a different. So WAN RTT is a double of your propagation time. And when I am saying that timeout is nothing but double of your round trip time. So we are waiting still for the acknowledgement up to that time. Even acknowledgement has not come, we will not immediately close the connection. We will wait up to some other time. That is nothing but a what? Double of your timeout period. So what is the round trip time or response time? Please understand. So here is the sender, here is the receiver. So sender plays the data onto the medium using a TT for data, and how much time you take, how much time the message take to make a physical journey from one end of the medium, and from other side acknowledgement is coming from other side to this side. This is for acknowledgement propagation, this is for data propagation. So obviously whenever you talk about wide area network, we will see that this is your RTT. So what is your WAN RTT? Your WAN RTT is nothing but double of your TP. Now let us go one more analogy. So I am saying that there is a sender and there is a receiver. So I send the data using a 1 ms of time, 1 millisecond. And now it takes some time to propagate over the medium as your 100 milliseconds. And that side, acknowledgement propagation is also taking 100 milliseconds. That means I'm going to wait for round trip time is 100 to 100 plus 100, 200 milliseconds. If acknowledgement not comes, we don't worry, still we are waiting. If acknowledgement not comes, we don't worry, still we are having a time. What is that? Timeout period. So what is your timeout period? Double of your RTT. Even after timeout period, there is a time to leave the connection between sender and receiver. One more double is required. So this is how this example is telling you that at what time your connection is being released, at what time your connection is out, at what time you are got receiving acknowledgement. So these three are interrelated each other. And other parameters are also there, my dear friends. What are the other parameters? Bandwidth, I already told you. In principle capacity, the bandwidth is always represented in the form of bits per second, in the form of digital, or baud per second in the form of analog. Observe carefully, bits per second, baud per second. So bandwidth is nothing but in principle capacity. So with the help of bandwidth only the sender can able to push your data onto the medium. So let us see what is the bandwidth. Capacity of the media to carry information. And capacity may be divided into channels. One is analog, the other one digital baseband and broadband. So baseband means only single signal, broadband means multiple signals. So your bandwidth is measured in the form of bits per second only. So second other parameter is the volume of the pipe. Very important question this is, my dear friends, in the exam. Simply he will ask that how many number of bits are fit in the channel. This is what he will ask naturally. And based on this volume of pipe only I can able to decide that what is your packet size and what is your window size. These are all the things I can able to get using volume of pipe only. So what is the volume of the pipe? Or number of bits fit in the cable at an instance of time. It is also called as a bandwidth delay product, also called as a capacity of a wire or a link of the channel. These are all the synonyms of your volume of the pipe. So the bandwidth delay product is a measure that the number of bits a sender can transmit through the system while waiting for an acknowledgement from the receiver. So I receiving acknowledgement from receiver, then how much data you can send, that is going to fill your, what I mean to say, in your pipe. Understand, my dear friends. So that's what is the meaning of bandwidth delay product. There are two varieties you can measure. One is a half duplex, bandwidth into 1 time TP. The other one is a full duplex, bandwidth into 2 into TP. So I will show you a diagram of volume of the pipe. Observe carefully. I say it's completely based on bandwidth only. My bandwidth is let bandwidth is equal to 1 bit per second. That means to the medium the sender can push, please understand, 1 bit per 1 second. So 1 bit per 1 second only. So if you look at the cable, then you are going to find only per 1 second 1 bit only. So soon after 1 bit come out, soon after 1 bit out, if you look at your cable, there is no data because it's already out. And the sender will send again one more bit. Sender will send another bit because your medium is idle. Again it is taking a 1 bit out. That means what? It takes a 1 bit to out is nothing but your bandwidth. So bandwidth is nothing but 1 bit per second. I am saying for every 1 second the sender keep on injecting one bit. That is the meaning of bandwidth. So now listen carefully. My bandwidth is equal to 1 bit per second. So here TP is also related. I will explain now. Now medium takes medium takes 1 second to pull out the bit, to pull out the data. Now I am interlinking your propagation time. Observe carefully. So let us say sender push the data onto the medium 1 bit per 1 second. What he is doing? He is doing a transmission time only. 1 second, every 1 bit he is sending. And this medium, the bit is taking a 1s to come out from your medium. So it is taking a 1s propagation time to come out from your medium. So soon after first bit is out, then immediately second sender is sending a one more bit 2, and bit 2 also takes a 1 second to come out because your propagation time is very lesser. Soon after, as soon as the sender plays the data, I am able to put it out. Now let us integrate in a different way. I am saying my bandwidth is equal to 1 bit per second, but this time distance is increased. Distance is increased. So when the distance is increased, automatically what will happen? Your channel has got much propagation time. Because of distance is increased, your propagation time is also going to be increased, because propagation time ultimately depends upon your distance speed only. But here I made a constant of sender's bandwidth. So sender bandwidth is the same, it is not changing, 1 bit per second only. So every 1 second he is placing the beta. So bit 1 first he placed, and it is taking, let us say it is taking a 10s your propagation delay. That means whenever sender plays a 1 bit, it takes a 10 seconds time to come out from your medium. Therefore what is going to happen? 1 second it make a physical journey here, and the second it makes a physical journey here, and the 10th second and the data will come out. Please observe, and data will come out. So this is how the meaning of a 10 seconds time. What the sender will do during this time? Sender is doing that for 1 second he pushed 1 bay, and for 2 seconds he is keeping another bay, and for next second he is keeping another bay. Likewise, what happened? First bit takes 10 seconds time to come out. So during this 10 seconds time, the sender is keep on injecting the bits. Therefore, at 10th second, the sender fill the pipe with how many bits? 10 bits. This 10 bit is nothing but volume of your pipe. Also called as a number of bits fit in the channel. Also called as a what? Line capacity, also called as your link capacity, or bandwidth delay product. What I did here, how did you get this 10? This 10 you got like this. How? The bandwidth delay product is nothing but bandwidth into end-to-end delay. That's what the meaning of bandwidth delay product, BWDB. What is BWDB? You were given bandwidth and end-to-end delay. My bandwidth is a 1 bit per second. Your end-to-end delay is a 10 seconds. So seconds are cancelled. Your final value is a 10B. It's nothing but 10 bits. So this is the real-time representation. Why you got a 10 bits into your particular medium. If you look at your cable like this, then you are going to see that 10 bits are inside, because it all depends upon that how speed you are propagating your data onto the medium. Let us increase it. Now, let us say my bandwidth is equal to same 1 bit per second only. There is no change. But this time I am taking a much distance. That means TP is increased to 1000 seconds. Why TP is increased? You know, distance is increased. When distance is increased, the propagation time is increased, then your medium is still enlarged with the bits, not physically. Your medium is enlarged with the bits such that how many bits you can able to see. What is the volume of the pipe? The volume of the pipe is nothing but your bandwidth into your 1000s. is nothing but TP. I'm talking about the off duplex only. So therefore, how many bits I can able to fit in this? It's nothing but 1000 bits I can able to fit in this. In this completely 1000 bits are filled. If other side is also injecting, both sides are sending the data and the delay is taking as a 10 seconds. Sender and the receiver both are sending the data here. So bandwidth is equal to 1 bits per second and both sender and receiver is sending full duplex channel. Then what is going to happen? Your TP is equal to same like 1000S only. And what is going to happen? Your volume of the pipe is nothing but your bandwidth into 2 into TP, 2 into your end-to-end delay. So therefore, I can see here 2000 bits because sender sends 1000 bits and receiver filled with 1000 bits. All 2000 bits are there in your volume. This is what is the meaning of bandwidth delay product. Product is nothing but multiplication between your bandwidth and your TP is nothing but product. Well, my dear friends, this is how you can able to measure the capacity of the link. That's the very important. What is that? The capacity of the link, also called as how many number of bits you can able to fit in the channel, also called as bandwidth delay product, also called as what is the volume of your pipe. There are two volume of your pipes. Let me conclude. There are two volume of the pipes. Volume of pipes are two. One is thin channel. The other one is thick channel. So what is a thin channel? Thin channel is nothing but low bandwidth product. Low bandwidth delay product, also called as a low volume of the pipe. And what is the thick channel? High volume of the pipe. It is called as what? High bandwidth delay product. So in Ethernet, if you consider 10 base 2 is your thin channel, 10 by 100 by 1000 base 5 is your thick channel. So what is a 10? 10 Mbps. What is a 100? 100 Mbps. What is a 1000? 1 gigabit per second. What is the base? Baseband signaling. What is the 5? 500 meters. And here what is the meaning of 10? 10 Mbps. Base means baseband signaling. 2 is nothing but 200 meters. Here distance is smaller. That's why TP is smaller. Observe my dear friends carefully. Here distance is 200 only. 200 meters only. So when distance is smaller, your TP is also going to be the smaller. And see 500 meters. Therefore here distance is up to 500 meters. Then what is going to happen? Your TP is going to be raised double of your thin channel. So these are the two volume of the pipes are there in the real time. So we already discussed what is the bandwidth and what is the volume of the pipe. And the third one is there, that is called link efficiency and throughput. What is the link efficiency and throughput? Let me do that before closing the session. Link efficiency also called as a link utilization, a line efficiency or channel utilization or channel efficiency. It is a fraction between your useful time and your total time. It's a fraction between your useful time and total time. It is measured in the form of useful divided by total, otherwise L by bandwidth delay product, otherwise TT by your total time, otherwise 1 by 1 plus 2A, otherwise L by L plus BR. BR means bandwidth into RTT. R stands for RTT. These are all the ways you can able to find the efficiency. But the most suitable, what we use regularly is nothing but 1 by 1 plus 2A. This is only we are using. This is being written like this. TT by TT plus 2 into TP. How did you get this? I will show you a proof. Observe carefully. Now I am discussing about link efficiency. Let us see. Here is the sender and this is your medium. Sender plays the data using a 1 ms time and propagation onto the medium. It is taking almost all something like 99.5 ms, and acknowledgement is also coming at the same time because both are connected to the same channel, so same distance and same speed. Now you observe carefully. I have transmitted a frame 1 or frame 0. So this is completely for your frame 0 only. This is completely for your frame 0. Now you tell me, what is that? What is the useful time of sender? Useful time of sender is nothing but he sends the data and he is waiting for acknowledgement, which is nothing but TT for data, which we are considering as 1 ms. And how much time is waiting? Please let us see. What is the waiting time? Waiting time of sender is nothing but your round trip time only, or acknowledgement transmission time, which is nothing but 2 into TP. So how much time is waiting? 99, 99, 198, 199 ms is waiting. So unless acknowledgement comes, I cannot begin the next transmission. Therefore, what happened? Once you get from here to here is your waiting time. Once you get the acknowledgement, again I push the frame 1. I push the frame 1 with the same time 1 ms. It gone there and it coming back, same time it is taking. Same distance and same speed. Therefore, what is your useful time? Next also is the same. Therefore, my dear friends, so because of waiting time, your efficiency it got down. So how much it is got down? Let me write. What is your line efficiency or link efficiency or channel utilization? Your link utilization is nothing but useful time of sender by total time. So useful time is every time I am taking a 1 ms, and total time how much? Tell me. Total time is nothing but what? Your transmission time and TP one side and TP other side, which is nothing but 200 ms. So ms cancel ho jayega. 1 by 200 is your efficiency. Out of 200 units of time, your useful time is only 1 unit. Remaining 199 units are what? Waiting time only. Let me write. So out of 200 units of time, only one unit is useful, and remaining 199 units are waiting. We already seen in the proof. Observe. So this is your waiting time, almost all 199 milliseconds. If I am saying another example here, say, for example, let LAN. You know LAN means what? Distance is reduced. As distance is reduced, TP is also reduced. As TP is reduced, waiting time is reduced. As waiting time is reduced, link efficiency is increased. As link efficiency is increased, your throughput is also going to be increased. See that relationship. So there are two important link efficiency parameters. One is a useful time, the other one your total time, and your link efficiency is always depends upon your distance only. So if I am taking let wide area network. So when you talk wide area network, you know distance will be very far. As the distance is increasing and propagation time will be increased, so waiting time will be increased and your link efficiency is going to be decreased and your bandwidth, actual bandwidth is also going to be decreased. So this is the association. The main link efficiency depends upon your how long you are using your channel, either a shorter distance or a longer distance, because it's completely depends upon a parameter called propagation time. This propagation time will give you waiting time at the sender side. Now, if I am saying another example, let us say now, let TT is equal to something like 1 microsecond and TP is equal to something like 200 microseconds. So what is your efficiency? Simply I can write 1 by 401. This is your answer. Because sender sent the data using 1 microseconds time, and the data has to propagate from one end of the media to other end, which is a 200 microseconds. Acknowledgement must come from other side to this side is a 200. Therefore, it is all together. Total time is a 401, but you are waiting for the acknowledgement 400 microseconds. So your useful time is only 1. How did you write? Useful divided by total. What is your useful? Your useful is a TT for data only. What is your total? Your total is a TT for data plus 2 into TP. Please observe carefully. Your TT is a 1 microseconds divided by your TT is also 1 microseconds plus 2 into 200 microseconds. That's why we have written 1 by 401. So here 1 unit is a useful time and 400 units are your waiting time. I'm talking irrespective of what stop and wait protocol. Now let us see another example. This time I am giving another parameter. I say let TT is equal to 1 microsecond. I am reducing the distance now. That means TP is reduced. TP is reduced to something like 1.5 microseconds. Now he is asking what is the L of U? It's superb. What is your L of U? Simply I can say that 1 by 4. Why 1 by 4? You know TT divided by TT plus 2 into TP. Otherwise I can write in such a way that useful divided by total. What is your useful? Let us see in the figure. Your useful is I am pushing with a 1 microsecond. Going that side is with a 1.5 microsecond. Coming this side is a 1.5 microsecond. So your total time is a 4 and your useful time is a only 1 and the rest of the time is a 3 microseconds is your waiting time. Therefore, simply I can write 1 by 4, otherwise TT by TT plus 2 into TP. I am not considering secondary delays. I am considering primary delays only. Secondary delays like queuing I am not considering, processing I am not considering, TT for acknowledgement I am not considering. Only 3 primary delays I am considering. So my dear friends, what I want to tell you for link efficiency is that your link efficiency is a fraction between your useful time and the total time. Useful time and total time, it all depends on two important parameters. Two parameters it depends. It depends on two parameters. What are the two parameters? One is a propagation time. This propagation time depends on distance. You know, if distance increases, TP increases. If distance decreases, TP is decreased. And the other one is your useful time. So your useful time is nothing but what? TT. So that's it, friends. This is how about link efficiency. So if you know the link efficiency, I can find the throughput. So what is your throughput? Throughput is nothing but actual transmission of your data. I have been given 100 Mbps, but I cannot able to use all the 100 Mbps because of so many delays are there in that. That's why throughput is actual transmission. Please use one-time speed.net, all of you, my dear friends, those who are online, and see that upcoming speed and outgoing speed and incoming speed and pinging response time. These three, you as a being a CS student is supposed to know how much is uploading and how much is the downloading and what is your pinging response time. Please go through speed.net from your Google and see that what is your internet capability. So all ISPs are used to cheat us. You need to know that if they will promise that they are going to give you 20 Mbps but real time you don't get that much, please prove yourself how much is the speed you are going to get. So now actual transmission, this is very similar to bandwidth. If there is a link efficiency 100%, as link efficiency is always down, then your throughput is also going to be down. So let us see, the throughput is an actual measurement of your data, how fast you can able to send your data. A link may be a B bandwidth, but we can send only T BPS. The T BPS is nothing but throughput and B BPS is nothing but your bandwidth. So your throughput is nothing but link efficiency into bandwidth or message size divided by your total time. So both are will give you throughputs only. So let me conclude with one example. I say bandwidth is equal to 1 Mbps and TT is equal to 1 millisecond, that is say microseconds. And your TP is equal to propagation time is equal to almost all 49.5 microseconds. He is asking what is the throughput? Simple answer. Throughput at the sender side. So the answer is throughput is nothing but link efficiency into sender bandwidth. If your link efficiency is 100%, your throughput is also 100% only. Let us check what is your efficiency. Is it 100% or not? So link efficiency is nothing but useful divided by total. What is useful? 1 microsecond. What is your total? 1 microseconds plus 2 into 49 point microseconds, which is nothing but 100. So therefore your answer is 1 by 100 into your sender bandwidth is 1 Mbps. So what is your answer? Your answer is this much. So this is your throughput now. It's nothing but link efficiency into your bandwidth. That's it, my dear friends, the today's session. So tomorrow at the same time we will meet 10 p.m. So I will tell you a link efficiency you can able to find in many ways, like a 1 by 1 plus 2a and TT by TT plus 2 into TP. If other parameters are there, how to calculate them, like queuing delay and processing delay, how to calculate them. And I also want to discuss a stop and wait protocol. So tomorrow we are going to discuss about link efficiency and throughput in elaborative manner, and I will give you a router structure, and from there we are going to see that how these delays are being reacted. After that I will start stop and wait protocol. This is a 10 p.m. tomorrow schedule. And next tomorrow, because the questionnaire I said that theory I'm going to cover on YouTube because parallelly I want to run, and the questionnaire problem discussion on delays I'm going to start tomorrow. Already 3 special classes are completed. So tomorrow 2 p.m. to 3 p.m. I'm going to have MCQs, multiple choice questions on delays. Please don't miss, because by seeing that you know everything, but while you are doing conversions and all you required, like MS to MUS and bits to bytes, MBPS to GBPS, many conversions are there. Naturally, bandwidth is in the form of 10 base, and your data is in the form of 2 powers. All those things we will discuss in the tomorrow's session. So thank you for sparing your valuable time, those who are online. And please you also watch Unacademy Student Learning App special class. This MCQs on delays on only Unacademy app only. So please download your Unacademy Student Learning app and search for Srinivasarao. You are going to find tomorrow's live session. Please join and make it a grand success, because without you we are not. Student is ultimate important object and ultimate important as far as Unacademy and myself concerned. Thank you very much, friends. Please do like them. Please give a valuable comments. And before you start solving the problems, please watch all my computer network classes so that you are going to get a good grip on that. Thank you very much. We will meet in the tomorrow session. So that is a 2 p.m. to 3 p.m. on Unacademy Student Learning app, MCQs on delays, and 10 p.m. tomorrow as usually YouTube session, which is based on stop and wait protocol and for the continuation of link efficiency and throughput. If you are having any doubts, those doubts you can ask me in the tomorrow's class. Thank you very much. Good night.